Good morning, and we are back for Remote Learning 19 Part 1. And I think I should start by just laying out the remaining few days we have with one another before the end of this semester. So we're going to have Remote Learning 19 today and Remote Learning 20 on Thursday. That'll actually be the end of new material. And then we will take Tuesday to review for a short final exam. That's going to be on Thursday. And this has been strange, let's just say, into the school year. Of course, we're used to it by now. But we want to make sure that we're not just looking at this the wrong way with putting a very stressful final in front of everybody. So I certainly am modifying the length of the final exam, modifying the value of the final exam. So the final exam historically, or according to the syllabus, is 10%, and it's going to be less than that. It's going to come in at 7%. And then it will be a final exam that does not cover everything from the semester, but just the most recent material. And I'll break that all down in 1 week's time on the Tuesday. But I'll also send out a practice final exam sometime between this Thursday and that Tuesday itself. Okay, just so that you have some awareness of what the final exam is going to be about. We'll also talk more about how that Thursday is going to play out. It is going to be a live test where I'll ask everyone to log into the Google Meet, turn their cameras on, and then when you show up there, I'll send you your personalized version of the final exam test, and we can hang out in there until you're done. Okay, so I'll continue to talk about that at the beginning of each of these videos, and I'll be putting together an email that announces all of that. But since we're here at the final couple of remote learnings, go ahead and say it. And okay, let's transition. Let's go into this particular lesson, which is from a new chapter. In chapter 9, we did a whole bunch of work on solving quadratic equations, those equations that have an x squared attached to them. And there are various methods that I'm not going to rattle off right now. But in this particular section of chapter 10, we're going to be solving for x, but instead of there being an x squared in the equation, there's a square root of x in the equation. Or for that matter, maybe I should more correctly say there's just going to be a square root in the equation with a variable in it. So we can peek down to this one. It's not necessarily a square root of x, but it's the square root of a x structure. Okay, so a series of examples will go a super long way in rolling this out. So that's what I'm going to do. I'm just going to progress with walking you through a series of examples that tackle most of the cases, and then we'll see where we are after 30 minutes, and there'll be an assignment for part 1. All right, so here we go. 10.3, solving radical equations. That is to say, solving equations with a square root or a cubic root or an nth root. Doesn't necessarily have to be a square root. So, and here in example number 1, we're going to solve for x, but as is going to be the case, a theme or a strategy for all of these problems is going to be to isolate the square root piece first and foremost. So over here, I need to get the square root piece by itself. The plus 5 is not in the square root, otherwise I would do this. All right, so fine, the square root is not in the plus 5 is not in the square root, so I got to get rid of the plus 5. So let's minus 5, as would sort of normally be the case. And then I've got 8 over here. Okay, well, how do you get rid of square roots? What's the opposite of square rooting? None other than squaring. I'm going to wrap that whole side and square it, so just be careful with my parentheses there. And a square root and a squared, those undo each other. And what is 8 squared but 64? All right, and then that is the answer. And I will just do a little check over here. And the check is that I should be able to put 64 in for x and actually get 13. The square root of 64 is 8. 8 plus 5 is 13. That's a good check. I got it. All right, now we don't have to worry about the plus and minus situation. If you mistakenly did that and thought, oh, hey, we did plus and minuses when we were rooting, maybe we'll do them when we're squaring, you would have negative 64, and if you put negative 64 in there, well, that wouldn't work out, right? Because we can't have a negative number in a square root. All right, let's go over here to B. And all right, so if the theme is to isolate the square root piece, I'm going to get rid of this positive 3 by subtracting it. And I still don't have this square root isolated. I need to get rid of the negative. So I'm going to multiply each side by negative 1. I could also divide each side by negative 1. All right, and so let's say I got a double negative for square root x, and over here I've got a double negative for positive 3. Okay, so that's good. Once the square root is isolated, you square each side. That kills off the square root, revealing x. And over here we've got x equals 9. Okay, so I'll do a little check on this one too, since we're warming up to these ideas. We should put 9 in there for x, and it should equal 0. And the square root of 9 is 3, so it works out just perfect. 0 does equal 0. Okay, so let's ramp this up slowly but surely, moving on here to example 2. And in this case, I'm going to stick with the theme, and that is to isolate the square root piece. So that is all of this. So I'm going to get that component by itself. That's going to require getting rid of the plus 3 and the multiplier of 4. Okay, so let's think about what we did way back in the beginning of the school year, sort of wadded piece of paper lesson. When you're doing algebra, you want to remove the farthest thing first. We're trying to get to this quoted component, the square root of x plus 2. So the farthest thing from that is the plus 3. In terms of order of operations, it would be this times 4 and then plus 3. This is the farthest thing. Okay, so I think everyone's good with that, but just as a reminder. All right, so now we've got 4 times the square root of x plus 2 is 16. Let's get rid of that multiplier of 4. And we've got the square root of x plus 2 is 4. All right, well, it's not just a root x, it's a root x plus 2, but I've got the square root isolated. It is time to square each side. Totally legal. You're doing the same to each side. That kills off the square root. We've got x plus 2, and okay, we've got 16, and we can do this last move in minus 14. All right, let's do the check on this one as well. So my check is that we should be able to put 14 in the x spot. Close that with a little tail, right? So that my 3 doesn't wind up in there accidentally. And let's see. Order of operations. Let's go inside of this grouping symbol, the root, and do what we're supposed to do. That's 16. suppose this is a question mark there. And the square root of 16 is 4. And that's 16 plus 3, which is 19. And oh yeah, it equals 19, like it's supposed to. So there you go, checks off. Perfect. Okay, so this one is different. We've got radicals on both sides. We've got the square root of 2x minus 1, and we've got the square root of x plus 4. All right, so if I could go back to the theme, that is to isolate the square root, in which case maybe we should say isolate a square root and then square each side. All right, so this side, the square root's isolated. It turns out that that's also true over here, but maybe it doesn't even matter. We'll just say, look, let's follow this theme. We've got a square root that's isolated. It's time to square each side. So I'll square this side, and I'll square this side. I could wrap it in parentheses if I wanted to, but that's redundant. We've got parentheses, which is a grouping symbol, and the square root, which is also a grouping symbol. So it's just a little overkill. I'm going to get rid of my parentheses there. Right. Okay, so square roots and squareds cancel each other out. And square roots and squareds cancel each other out. And that looks to me like I just got a run-of-the-mill algebra problem. You get the x's on one side by subtracting x, and bring this constant over here to join that one. And 2x minus x is x. Oh, sweet, we're done. X is 5. Okay, so I do want to check this also. So it starts with the square root of some stuff equals the square root of some other stuff. And let's see, it's supposed to be 2 times, and I put 5 in there instead, minus 1. And over here it's 5 plus 9. Do these wind up being the same? 2 plus 5 is 10. 10 minus 1 is 9, square root of 9. And over there, square root of 9. Okay, fine, we're done. 3 is 3. Okay, so I don't know how many times I've said the theme of the current lesson, but I'll write it out, right? So let's get the theme here. We'll do it in green. Will we do it in green? Yes. Okay, so isolate the square root component and then square each side. That's the theme. Maybe I'll even write that out front. All right, that's the main takeaway that we got going on so far. Isolate the square root component and then square each side. Okay, so coming over to this side, first and foremost, we're going to notice that the theme has, now changed a little because we're not going to be squaring each side because this isn't a square root, but I'll bet you can guess what we're going to do. What's a clever way to get rid of a cubic root? A 3-for-1 trading scenario, and yeah, we're going to cube each side. All right, so we'll cube this side, and then I will cube that side. And that's looking like a pretty nasty number, but okay. Cubing and cubic rooting, those undo each other, so those are canceled out. And then over here I need to do 12 times 12 times 12. And let's see, that is 1,728 snap. All right, well, now at least we've just got a run-of-the-mill algebra problem. Add 2, 1,730, divide by 5, and 1,730 divided by 5 is 346. All right, now I could check that one too, but I think I know that I'm just going to be turning to the calculator to do the math. Well, you know what? I think that's actually worth doing, just to remind you how to do the cubic root button on your calculator. Okay, so let's check this one by doing the cubic root of 5 times our answer minus 2, and does that equal 12? All right, so let's see. We need to do this grouping first, and we need to multiply first. 5 times 3, 46. And 5 times 3, 46 is 1730 minus 2. So now we're looking at the cubic root of 1728. And I mean, if you're following this logic, after all, we did cube 12 to get 1728. So doesn't that mean that the cubic root of 1728 is 12? Sure it does. Okay, but let's go ahead and show you on the calculator so that you feel comfortable doing that. All right, I'm just going to pull up the HP calculator and show you where to find the button to customize the index. In this case, the index is 3. Okay, so let's just go home here, and we've got the square root button here. It's attached to the x squared, and then we've got the nth root. This is the customizable one here, attached to the customizable exponential function x to the y. So it's this button that we're after. So we're just going to hit that one, shift, and grab it. And then it looks like it's hovering over. It doesn't look like it's exactly positioned in the right place, but that is the index. So we'll put 3 there, and then we'll come over there, inside of there, and put our number 1728. All right, and then the computer's asking itself, what times itself 3 times makes 1728? And that's 12. Okay, great. So we've got 3 more problems here where the theme is to isolate the radical and then raise each side to the appropriate power. So then that's a little extension of the earlier theme, which was just to isolate the square root and then square each side. So I'm looking ahead to this one. All right, so let's just do these few. And let's see, on this one, I'm going to isolate the square root of x plus 4 by subtracting 7. And that's 4. All right, time to square each side. Oops, okay, so go back to blue here, and we've got x plus 4 is 16. And subtract to get 12. All right, let's just do a check in our heads. I'm going to take 12 and put it up there, and that's 12 plus 4, which is 16. The root of 16 is 4, and 4 plus 7 is 11. So that checks out just fine. All right, I'm going to get rid of that. Okay, so let's move over here to the so-called green problem. All right, well, I've got a square root isolated, so I'm going to square that side and square the other side. All right, lucky for me, it's as easy as this squared kills the root, so the argument comes out of the square root. Same thing over here. All right, and then let's get the x's together. I like having my x's over here on the left side. I'll slow this one down a little bit. And Okay, and then I need to get x by itself, so I'm going to -1 to get rid of that +1. And finally, I can either multiply or divide each side by a negative. This time I'm going to divide each side by a negative, and x is 8. Okay, well, let's check that one in our heads. We've got 8 up here. 8 times 3 is 24, plus 1 is 25. The square root of 25 is 5. Over here, we've got 8 to put in here. 8 times 4 is 32. 32 minus 7 is 25, and the square root of 25 is 5. Okay, so when I plug them in, everything works great there. All right, and then we've got this last one over here, which is a cubic root of y minus 4 equals 1. And all right, I'm going to isolate this cubic root, isolate the radical, or isolate a radical, and I'm going to do that by adding 4. So I now have the cubic root of y equals 5. All right, and then now you need to raise each side to the appropriate power. That's going to be the power of 3, because in order to get rid of a 3 index, then you need a 3 power. Cubic root and cubes cancel each other out. Okay, so over here, then we've got y by itself, and 5 times 5 times 5 is 125. All right, so checking that one, 125 inside of a cubic root. What times itself? 3 times makes 125. 5 minus 4 is 1, and it works out just perfect. Okay, so that's a pretty quick lesson there on the themes of, let's come back over here and get this theme. All right, so I think that the theme, the takeaway, the main thing for you to remember is that you should isolate the square root, component, and then square each side. All right, now, if I could take you over to this one where things are a little different, let's get our second theme, which is really just a variation of the first theme. See if we can get this into words. All right, so theme, isolate the radical, and then raise each side to the appropriate. Hey, what happened there? The appropriate power. All right, I think I can live with that. Let's just make sure that's okay. Okay, other than I just put a period instead of an exclamation point on that one, I think I'm good. All right, let me do a quick little time check. All right, I'm a little short, but I know that the next section, part 2, is going to ramp things up quite a bit. So that's fine. I'll stop right there and get you going on assignment number 1, assignment part 1. Okay, part 1 is here, and you can see that the ones over here involve a square root where there's just a variable inside of the root. So then it's isolate the root and square each side, and then you'll be done after you square each side. Over here, what's inside of the square root is a binomial each time. So you need to isolate the larger square root with its binomial argument, and then once it's isolated, square each side, and then there may be 1 or 2 algebra moves that you have to take after that. All right, let's see. Do I want you to check your solutions? I know that's always annoying. Okay, so here's what I'm going to say. Check a few of your solutions. Okay, so maybe if you run across one that seems problematic, you're not totally sure about, then you can check that one. Why don't you check, at least 1 or 2 But I also understand it's a little annoying to go back in and plug them in all the time after you've just done the problem. Okay, that sounds great. Pop into the meets, ask your questions, and then when you're ready, after you've done all of these, you can move on to part two.